Hi everyone, my name is Sebastien. Thanks for coming to my talk. I'm going to talk to you about transitioning your tools within an organization. So a few years ago, my company, we decided that it was time to change our analytical platform and the tools we were using. And so we're just going to walk through why we decided to change our tools, how we decided which new tools to use, and then what we learned from the transition. It's pretty neat because usually when you go online, you'll see a lot of discussions about, tool A is better than tool B and so on, but no one really talks about, hey, how do you make the jump from one to the other? So we thought this would be a pretty interesting topic to cover. So a little bit about my company and myself. I'm Sebastien. I work for Socratic Technology. We're a marketing consulting firm based in the San Francisco Bay Area. We've been around for 22 years. And so this story kind of starts a few years ago when I joined the company to start our data science initiative. And I've been there 4 years, and I do data science. I lead a small team. We're 2 currently, but that number changes pretty frequently apparently. So the before picture. When I joined the company, it was very much a traditional market research company, and the analytical needs, or really the analytical work that was being done, was mostly simple one-offs in terms of statistics, and so they would just kind of run frequencies, means, and so on. This analysis was being done by the project managers, and they would use entirely just SPSS and Excel. So I think everyone knows Excel, how that works, how that doesn't work. But SPSS is kind of like SAS. It's very much a statistics-oriented package. It's very limited, but the little part it does pretty well. But there's no scripting ability, there's no for loops, there's just not that much to it. Especially then. I know they've recently changed a bit their effort to make it a little more programming savvy, I guess. But they're mostly relying on Python to do that, so that should tell you a bit about our decisions. So those are tools, and so what happened is we started to look at more serious data rather than just surveys. We started to look into client databases. We also wanted to do machine learning and other things. And so just kind of like the catalyst of the choice was obviously our analytical needs were changing. And anytime your analytical needs change or the kind of work you want to be doing changes, you obviously want to be putting in question, I feel like this is pretty loud. You want to be putting in question the tools that you're utilizing for that. And as we started to look into more and more capabilities, the limitations of the SPSS Excel combo became painfully obvious. Like I said, no scripting, no for loops, it just was a mess. Lastly, costs. I don't know if you know, but SPSS is $20,000 per user per year. So anytime you're considering reducing costs, that was one that would usually come up. And if you can come up with a viable alternative, it made my bosses really happy. So these were really kind of what we were facing, and that's when you're looking at that and you say, okay, we need a new tool. So what did we want out of the new tool? Before we even started the search, the important thing was to define what we wanted that new tool to do. First of all, we wanted to replicate all previous functionality, right? We don't want any disruption in our production. We want our project managers to be still doing whatever need to do for the projects. We want the clients to be receiving the same things. We also wanted to automate a lot of the very simple work, repetitive work that had been going along so far. So, this one of the limitations of our previous tool. If we're getting rid of it, we might as well get rid of that main limitation we had. Because SPSS was very much a manual process, and Excel is as well. Obviously, a lot of the stuff that was being done was done by hand each time, so it was very error prone. You could make a typo or something, and minor rounding errors. So anything that could reduce those kinds of errors would be great. We wanted consistency across the teams. Everyone had their quirky little way of doing their analysis, the little twist on it. And what we were looking for was an experience where our clients would get the same products and deliverables regardless of who they had been through. Obviously wanted to improve our efficiencies, be a little more efficient. It's always something you should consider when looking at new tools. And because we're a smaller company, I didn't mention that, but we're about 50 total, and these tools and these platforms are being used by roughly 20-ish people. When you're that smaller group, you do want to maintain, a single code base so that collaboration can easily happen, you can share things, and not place any artificial barriers. And actually, I'll mention a little bit more about that later. So here were the initial contenders. I'd use the first one all the way to the left is Wolfram Mathematica, which is a great mathematical software if you've ever used it. But that's just what it is. It's a great mathematical software. And so it's not all that great for developing heavy analytics things. I know they're also trying to spin it as they're very capable of doing big data type stuff. It also mostly relies on Python. So we quickly discounted it. And then obviously, you know, the big R versus Python thing. Now, unfortunately for me, the name of the conference gives away which tool we ended up going with. And we obviously chose Python. I do want to quickly say, for those who are like more in the R camp, which I'm pretty sure there's not that many here, but you know, this was being done a few years ago, and I think when I'll mention some of the factors, R was much more limited in those areas than Python was. So for the main factors, so first of all, cost, right? If I looked at the previous three, Mathematica still had a licensing cost versus, you know, free for both R and Python, so that was pretty simple. But really, when I'm looking at the limitations in the long-term plans, eventually we were looking not only to build these capabilities, but also to make them more accessible, place them within widgets, make apps, and so on. And as long as you're creating some sort of other infrastructure, we preferred a system in which we could keep everything in a single language. So, you know, if you're thinking about we're going to create an entire web platform, you can do that in Python. You could do that in Python then. Oh, and it needs to interface with our SQL database and some other stuff. Just in that sense, it was much easier to keep it all within Python than it would have meant to keep it all within R. So that was kind of the really, but in addition, obviously, that they met all of our initial goals. And then lastly, you know, I was mostly familiar with Python, and this was a project that I was mostly spearheading, so, you know, I'd rather go with something that I was a lot more comfortable with, especially since a lot of it would rely on educating others on it. So that's kind of how we chose those elements. So how, now, you know we need a new tool. We know what our tool should be based on. It's based on Python. So our first attempt. There we go. First attempt. What does that look like? So again, echoing the same functionality that SPSS had, which was kind of like this notebooky way. So, you know, it was pretty obvious we should go with IPython/Jupyter. At the time, it was about to change names. So you now have a company full of people who still call it IPython, I guess. So it really was to maintain that workflow. And then to supplement that, we added our own custom library, which we called Plato, because Plato was Socrates' student. And basically within it, we baked all the functions that I've talked about in terms of goals. It had a lot of our analyses turned into, you know, functions. It had a function within it that would call to our database and pull data and so on. So it really had everything you would need, so that you would just need that library and then IPython. So if I was talking about a diet, this is kind of what the before and after would look like. So this is SPSS code, quote unquote, I guess syntax is the appropriate thing. This is for one method we use quite a lot, which is PCA, which is dimension reduction. But the part that's on screen, I mean, you can even tell the first part is kind of reformatting it, and as you can see, there's no for loops, right? Like, oh, you want to flatten data, you still have to spell out every single variable, and you can forget one of them, and it won't tell you forgot one of them until you know your numbers look wrong. So it's pretty awful. And so this is how we replicate it, that entire functionality. So it's very clean, very simple, you know, import statements. I place import pandas as SPD because it's now become a habit, not a bad one to have, I guess. But yeah, you know, just the first line is pull the data from the database for this project. The second one is run PCA on these variables. Clean, simple, just met all the goals. The next piece was our propagation strategy. So this is kind of what the typical project structure looks like. We have a project lead who's our client contact, you know, kind of oversees everything. We have a project manager who makes sure the project is on track. And then we have also research associates who do a little of the groundwork, right? So when I was showing that SPSS code, they would be the ones writing it under the supervision of a project manager. So really our idea was to go from the bottom up and slowly transition the tool set. So from the entry-level people, and then kind of as they would grow and other people would grow, we would move up to the next stage and so on, so that eventually, you know, all those blue, boring SPSS squares became magical green Python ones. So we went through and did that, and some successes. You know, as I mentioned, we managed with our library to make everything into simple one function or couple function calls, simplified the workflow quite a lot. Obviously, now that everything was pretty much fully automated, it went really fast, but there was also no errors because human involvement was reduced to an absolute minimum, which I found many times is the only way to guarantee almost zero errors. And yeah, turnaround times, and obviously to supplement kind of the knowledge, even within the library, we had written a pretty comprehensive documentation with a lot of examples. I don't know if you've ever seen, like, I guess we kind of copied on the NumPy/pandas documentation, where even if you pull the doc string, within the doc string, there's 5 examples with, input, output type things, and that actually helped us quite a lot. It helped people, to have examples of the code in there. So that was like our big successes. The issues we ran into. So writing a Python library is easy, as everyone will tell you. Writing a good, maintainable, future-proof library is very hard. And so, as someone who was mostly trained in terms of writing models that would work, my data science background is mostly from physics. Basically that, and also support, before people had issues with SPSS, they would pick up the phone, call IBM, and someone will walk them through their problem or just give them the solution. Here, even though you can copy paste the error message into Google and get 15 Stack Overflow arguments over which solution is the best, you still have to go through them and decide on implementing. So we had to counter both of these issues by hiring someone and helping us out, manage the code base, clean up all my sloppy code, because there was quite a few not so great things that worked, but whenever you're building future-proof things that just work are not necessarily the best, and also helped out a lot with the support and the training. But really, the main issue that we ran into when trying to deploy this is that nobody wanted to use it. And that's a pretty big problem. Because you're saying, hey, here's a new tool, and everyone goes, it looks neat, nah, never mind, I'm going to go back. So, one, nobody liked it. The first one is pretty simple, and I guess as someone who works in a marketing company, we should have seen it coming, is perception. So when I think of Python, right, or I guess like any of us in this room, this is what we think of. We think of all these amazing libraries that have been out there. You can think of like all the nice and awesome ways you can combine them and create brand new things. This is really like what I say I think, but this is really what I think of when I think of Python, right? This is just this magical, simple language that gets anything and everything done, and it's just the best. For non-technical people, this is what Python looks like. This is a fun fact. This is from the data frame constructor within the pandas library. But they really see it as like, even if you try to sell it to them as this magical, simple tool, they still see it as this technical programming language that is complicated and has classes and subclasses and definitions and for loops, and they're very put off by it. So there's first of all like this initial barrier of adopting a new tool that seems very much intimidating. The second part was the propagation strategy that I mentioned earlier. So when we were actually at this stage and we started to introduce the language to the lower level people who were actually the ones mostly using these and who were kind of semi-happy to be using it, semi-afraid to be touching this thing. But really what was going on was this. We basically created this barrier between the low-level people and the project managers who were still on the old tool, and as a result could not necessarily oversee as well what the research associates were doing. And so obviously project managers and project leads were not happy that the people who were supposed to be helping them were using a tool that they had no idea how to work with, how to control, how to proof, how would you even proof that work? Oh, well, this new guy at the company tells you this is error-proof, but how do you really know? So that also created a lot of resistance within the rest of the organization for the propagation of that tool. And then just kind of like some they weren't as big drivers of it, but also issues as well. There's some resistance. Some people had been working there or in the field for 10 plus years and had been using SPSS, and they were just very happy with SPSS for 10 plus years, and why do I all of a sudden have to spend time thinking of this new tool? Obviously, you also need to train people to start using these new tools, and once Q4 hits in the marketing world, that's when the busiest time of the year wraps up, it starts, and comes September, October, no one has time for training sessions. So here's a tool you tell them will save them a lot of time, but they don't even have the time to think about it. Also the implementation, the way we approach it, we assumed that everyone would be as comfortable and friendly with Python, as we were. Turns out that's not necessarily true. Just a little bit covered by the perception, but also some people have a little more trouble understanding programming, and that kind of mentality. And lastly, there are some people who are just not happy about, losing the ability to do their little work. and they felt like they were giving up control over how analysis was being done. And at the same time, we were taking control with them, but we weren't really offering them, a trade-off at all. Even, saying, well, instead of control, here's what you get. We were just saying, tough luck. It's the way it should be done. Bad statistics do not belong in this company. But it still is not a conversation they would enjoy really having. So just kind of wrap up everything that didn't really work with that. Python is intimidating for non-programmers. Your propagation strategy should not include barriers, especially when up front you thought about, hey, I should create a system that doesn't lead to internal barriers, and then you create a system that leads to internal barriers. I guess should have seen it coming. Obviously, you need to think about realizing the transition is a time and effort rich process, and it does need to take time, and it does require a lot of effort. And people realize that effort is there, and if you offer them something that's slightly just as easy or slightly easier, that effort is not going to be worth it to them. And to aggravate things, people tend to overestimate the effort required to do something new and underestimate the benefits from it, which again, as someone who works in a marketing company, should have seen coming. So what do we go from there? Well, after a few heated discussions within the company, we had to rethink the strategy and the approach, and that's where you kind of have to start from scratch and go, okay, well, let's go at it a different way and see what we can improve on it. So, second attempt. So just kind of like resume, obviously our goals were always the same initially. The initial ones still apply. We still want this to be the same. We still want it to be automated, reducing errors. But really what we were trying to do now in the second round was make it simple to use to the users, and then make it a lot more approachable. We wanted this to be like this friendly, nice, easy solution that it would be a no-brainer that you would do over SPSS. So this is really, especially the last two, and here they're bolded, but really they were the driving kind of considerations we had in the second wave round. So somehow we just had the crazy idea of putting everything in a web portal. And so this is kind of what it looked like at the beginning. Unfortunately, can't show the current version of it because it's proprietary, but it was called Workzeug because one of the persons on the team thought it was so funny that the word in German for tool literally translates as work thing. But so basically what we have here is, every interaction was through a simple web GUI. Each screen would carry very simple instructions, kind of again thinking of like how we had the documentation on there. But this time, it just was a GUI which we're all familiar with, right? What a Dropbox and stuff like that looks. The output also, we made it so it would form, instead of just giving you tables the way that, pandas would return like a data frame or so on, really the idea was to get that output as ready for the final report as possible, so that in addition to not only being simple to use and friendly and fast, when you got the result, all you really had to do was copy paste something straight into PowerPoint, and you would have it and it would be there. And then obviously we simplified as much as possible and kept every single page, single function, just stressing on the simplicity. So here's the ways in which it contrasts from the previous attempt. Web GUI, no need for training whatsoever, right? You just go on the page. I think the most effort you have to do is periodically send out an email to everyone saying, hey, we added a new, here's the new website through which you can do this thing. We also changed the propagation strategy. Instead of going by different levels and creating those barriers that I was mentioning, we distributed these tools to the entire company all at once. But to not overload them, we basically introduced each functionality piecewise, so that basically people were just getting acquainted with the interface. If for later versions we needed to improve something else, it would come up, but it would only affect a small piece of it. Just more and more it became this thing that was more and more compelling to use. We also realized that you can't immediately get rid of the previous version and just ask everyone to be on this platform like we had done with the entry-level people. So at that point, we started to reduce the number of SPSS licenses that were available, but not removing them altogether. So for instance, we're still kind of in that process, but we have, we've gone from having 20 licenses of the stuff to just 2, which $20,000 a pop is pretty great effort already. And so not only were we replicating old functionality, we were also starting to introduce new methodologies that, as a data science team, we had developed, and now we were giving it to the hand of the teams, and not just saying, hey, contact us and we'll do this for you. It was a case of, hey, here's somewhere where you yourself can do that, and that was a trade-off we offer, in exchange of taking control off of their hands. And these reasons were actually pretty compelling, and that actually worked a whole lot better. So again, just stressing out, this is what an input page would look like. Very simple. You just choose your files. There's just an instruction quickly that tells you, hey, this is what the formats it should be in, and what the file should include. Just make it really simple. And again, just to make it even more friendly, we added a few notes of humor. This is what a loading screen looks like. Actually, it's like the shark dancing. And so this new tool really worked really well. So what were the main lessons for us? Like I said, changing tool requires a transition period. You can't expect to come up with something better and then everyone will go, oh my god, this is the best, and I'll just use it. Like you slowly have to be weaned off the previous one and introduced to the new one. You obviously, as you develop these tools, and that's something that, I was particularly guilty of, and I think we're all kind of guilty of it in this data science world, is we need to keep in mind the users and their perceptions. We all love advanced stats, but really these things need to be boiled down to what it is that our end users care about. Just thinking about the consultancy world, right? Like I will run models for clients and find statistically significant findings or not, but in the end my client doesn't care all that much. They just go, oh, is this a good idea, yes or no? And so this is really something that, even internally, you have to think about of, what is it that they really care about from the tool? Do they really care about the simplicity, or do they just want easy, nice results? And so I mentioned that the output was nicely formatted with them, and they cared a lot more about the nicely formatted output than the fact that this process was turned from 15 steps to just 2. Also, open source doesn't mean free. Is also something that we learned. Like I said, maintaining code and supporting will require time, will require resources, and even though those are not explicit costs, there's still costs that you will incur and that you should take into consideration within your company. We're mostly lucky that SPSS is a tool that's horrendously expensive, but if you're mostly relying on something that's costing you that much, not that much, but helps out with support or streamlines it in some other level, you have to consider that trade-off. And then obviously, whenever you introduce a new tool, it has to be worth it for the end user. You have to make it that much easier for the users. It has to be worth it for them, and some sort of trade-off, which, again, also something that we had not considered at all. So for future plans, there's also some other elements we haven't fully responded to yet as we're building this tool. We're obviously working on it and optimizing it. But we also have now the weird case of power users, the ones who enjoyed using SPSS and all its, to get it to do this one weird obscure thing. And so for that, we're actually working on getting some sort of IPython server in the background that can also be accessible from that platform. And then that way we can control their environments, because there is such a thing as knowing just enough to be dangerous, and we have quite a few of those in my company. But yeah, so we're also thinking about creating some sort of system for them to use. Improving the layout and arrangements, I think we're all familiar with that. That's just, we're obviously tracking how people are using these tools and improving them. The nice thing with our solution is that as a web thing, you can be constantly updating it, and we're constantly adding new tools and new capabilities. Right now we're into this huge foray into text analytics, actually, and it's really nice that all of a sudden, for the teams, they're able to do pretty advanced text analytics from this simple screen. And I think the next thing, because people cared so much about output being nicely formatted, we're also looking into more advanced charting and reporting tools. I think some clients have expressed interest in receiving these dashboards instead of reports, so we're also kind of using that as a platform to improve kind of our deliverables, which is a nice unexpected consequence of this entire effort. So yeah, thanks a lot. That's an overview of how we did it. If you have any questions. Yes?
How long did it take to build that website?
The website itself, well, like I said, because we built it piecewise, I think it took about a month to just get the template going, and then a lot of these are being generated with Django and Jinja, so that you just have the elements and then the output pages, because the charts have to be generated each time. So Yeah, it also avoids us knowing. It also avoids the need to know too much JS or HTML development, which do not want to get into. I think I've heard that a lot this entire weekend. It's just I don't want to do JS. So yes.
You mentioned building out a library called Plato.
Yes.
With like, I know some of this is probably proprietary, but what kinds of things were you trying to automate when you built out this library?
So there's a lot of functions like people would take questions, especially from our survey database. There's a few ways that questions are being formatted that in a database mindset make a lot of sense. But then once you need to start working with the data, it's a little more annoying, to put it mildly. So there's a lot of transformation of grouping things and turning them into a single table. So for instance, that entire process is just automated. You just point it out to the right point. You tell it, hey, do this transformation on these questions, and it outputs the perfect table that people want. It also formats things in the way that is the way we like to see them within the company. I know stat testing between numbers. Sometimes we do it with like adding a letter at the end of the percentages, and obviously because that's our way of doing it internally, no one else does it. So we bake that into that library as well. And then now the Plato, even though like we took it off of their hands, we're still maintaining it as the backbone of that web platform. So now it has our pricing evaluations. It really has like all of our methodologies built into it. Yes.
So you mentioned you went from SPSS to Python, which is what my company started did too. We were trying to do that shift. Do you think it would be making that case be easier now today if you were versus R, since that our library is built out pretty well? You can use Spark with R, you can make database callable R. Do you think that transition might be difficult or easier nowadays?
That's a good one. Especially when I was preparing for this talk, and the one reason I was going to talk about like, oh, well, Python just does web stuff on its own, and a lot of people are like, well, so does R now, right? So that I don't know. I think so. I still think really, that picture of like, how are you flying Python is still kind of how I keep that in mind of, they've added a lot of things to R, but in the end, it's just some sort of analytical tool as opposed to a programming language on which entire companies have built everything they do. So. I mean, if your scope is limited, and it's going to have some limits and it has to play with other elements that are already built in, I mean, yeah, I think there's a better case for R versus Python if, eventually you hope that the entire organization will run on it and it will plug into a lot more different things. I think Python still has a bit of an advantage. Yes?
This is simple, but what do you use as a code base? We're starting to learn a lot more R and Python in our team, but there's been some challenges with keeping things consistent with newer programmers. I'd love to hear if you have thoughts on sort of how to either centralize that or enable people to do that themselves.
Yeah, we have an internal, so obviously the data science team and some of our programmers are contributing to the code base. We have an internal Git server because again, unfortunately, one of the downsides of being a consultant is like some of your clients require everything to be on premises and that kind of stuff. So we have an internal Git server, and so we'll do regular push pulls. We'll have code reviews and so on. That's actually helped quite a lot. And then Slack also is pretty great for talking code over with other people. All right. Well, thanks everyone for showing up for my talk.